Hello everyone, this video then is part 2 of our hazards revision. So the first part covered tectonic hazards, this part of the video is going to cover atmospheric hazards. So if we're talking about atmospheric hazards, it's really important then that you understand the global atmospheric circulation model. So all global atmospheric circulation means is the transfer of heat from the equator to the poles by air. Okay. So if we're starting to think about what's happening here, we need to consider first what we've got happening at the equator. So at the equator, we've got our lovely sun, and our sun then is going to start to warm that air. So as that air warms, it's going to start to rise, and I'm drawing on the arrows at the same time. And as that air rises then, it forms a nice low pressure belt. So with that low pressure then, the air is going to start to cool, and it's going to start to move away. Okay, this is going to happen above and below our equator as well. So at 30 degrees north and south, so again I'm drawing over it with my red pen here, well, that cool air is now going to start to sink. So if we look at what's happening here, it's sinking back in or sinking back down. Okay, and that's going to create our high pressure belt. So it's starting now to move back towards the equator. Okay, so those would be what we call our trade winds. You can see they're drawn on almost here, aren't they? Okay, so if they're moving back towards the equator, we call them trade winds. If it's going towards the poles, then we call these sort of westerlies. Okay, important to note obviously that our winds are curved here because of the Earth's rotation, so that would be our Coriolis effect. So if we go back to what we've got happening at each point here, we've done what's happening at the equator, we've talked about 30 degrees north and south, so now we want to think about what's happening at 60 degrees north and south as well. So at 60 degrees north and south, well, our warmer surface air is going to rise again. That's going to create us low pressure. Some of that air is going to move back towards the equator. The rest is going to go towards the poles. So therefore at the poles, our cool air is going to start to sink, and it's going to create a nice high pressure, and our air then hopefully is going to flow back towards the equator. So that's what these bands of air that we've got happening right the way around the outside here, our cells, are showing us. Okay, and all these are just named after where we would find them. So if we think then a little bit about how this might impact the weather, we can annotate this on. So we might say, well, actually, at the equator, so draw a little arrow here, well, at the equator, if it's got the sun mostly direct overhead, we'd expect to see quite hot sunny conditions. If that air there is quite warm and moist, it's going to rise. We'd also expect to get a few rainy conditions. If we think about the sort of climate we've got around here, ideal for things like rainforests. If we think about 30 degrees north and south, well, most of the moisture's already been released. So here, I'm just going to annotate it at the bottom. I might say, well, actually, we've got some low rainfall. And last but not least then, if we think about 60 degrees north and south, well, the warm air is going to rise. So that then is mostly here going to create our cloudy, and I'd say rainy as well, conditions. Okay, so you might be asked that in the exam. So if we thought about what we're getting in terms of weather, and I'll highlight those here, make them nice and clear as well on the diagram, we can start thinking about how that might influence our hazards. So that could well influence our tropical storms. So tropical storms love low pressure systems. So they need low pressure with nice intense wind and rain. Okay, so if we think about where we're likely to get them on this diagram here, okay, well, we can almost annotate and have a bit of a guess. Okay, so they like to be sort of between 5 degrees and 30 degrees north and south. Okay, so we on our diagram here are going to be looking sort of in this region either side of the equator. Okay, so I've drawn them on in yellow. That's sort of our perfect place really for us to get tropical storms. So they love it there because it's got that low wind shear. The sea temperature is about 27 degrees. It's got that great low pressure. So if we sort of zoom out a little bit, you see down here, I've put a nice cross section of our tropical storm. So next to this then, we can annotate on exactly what happens for us to get our formation of tropical storms. So let's put a nice subheading, structure our vision. So the first thing then we know that's going to happen is that our warm water is going to evaporate. So let's write that one on. I've got it. So if our warm water is going to evaporate, well, that evaporated water then is going to rise and it's going to condense. So that there is going to equal lots of energy for our tropical storm. Okay, if that's happening then, well, it's going to create our wonderful low pressure that we're after. So we can say here, well, low pressure drives our surface winds. So again, lots of energy here. Well, next up then, we would say, well, our easterly winds are going to start to cause that rotation. So let's put easterly winds equals movement. So that would cause our tropical storm, in this case, wouldn't it, to move west. So then, our tropical storm, we would say, well, storm gets stronger as it starts to move over water. So one of our main energy sources then is that lovely warm ocean. Okay, so there's nice quick 5 steps for tropical storm formation. Okay, important to note obviously that we would have the full force of our Coriolis effect, so the idea that we've got this spinning happening, okay, because of the rotation of our Earth that's causing that bend in the winds. Okay, again, look at our energy sources here. Okay, so our big energy source would obviously be the water. So remember, storms lose energy as they move over land or cold water. So we need that ideal temperature here. In fact, let's write that on. We want that ideal temperature of 27 degrees. Okay, so if that's the formation of it, also super important then, do you know sort of the features of tropical storms? Okay, so usually, and this picture here does most of the work for us, we've got our eye right in the middle. Okay, so our eye, if we draw over it here, is this area that's in the centre. So here, we've got loads of low pressure, we've got light winds, not much cloud or rain, and typically it's got a higher temperature. Our eye wall would be this area here on either side. Okay, so that's our spiralling air with nice strong winds and storm clouds. So normally this is the area that's got the torrential rain and the lower temperature too. Well, that's slightly different then to the storm's edge, so the outer areas. Okay, so they've got light winds and scattered clouds, so a little bit of rain, so lighter than it would be in the eye wall. It's a little bit warmer as well. And of course then we've got this nice circular shape that we can see here as well on the diagram. Okay, so those are all the things we'd look for if we were sort of looking for features of tropical storms. So we've done a couple of bits already, haven't we? So we've sort of done global atmospheric circulation, we've talked about tropical storms, and of course there's lots of management that goes into those as well. Okay, if it was me, I might have a look at the Typhoon Haiyan video as well. Okay, that'll talk you through again causes, effects, and also then how we can start to manage that as well. Okay, super important, especially in your exam for those 9 markers. Okay, so one sort of hot topic at the moment then is the idea of our weather hazards in the UK. Okay, so we might say actually the UK, we're presented with lots of different weather hazards. Okay, so we're getting lots of strong winds, we get heavy rainfall, we get snow and ice, we get drought, heat waves, so we're getting a little bit of everything. And one big thing at the moment is you might say, well, actually, the UK's weather is becoming more and more extreme. Okay, we're starting to see more of these things. So in the exam, they might ask you, or do you sort of agree or disagree the UK's weather is becoming more extreme? So it would be useful to have some ideas to back up all of those hazards that we said we were getting. So the heat waves, the drought, the rainfall, the snow and ice are happening. Okay, so actually here's some key points then that I think are well worth noting down for your revision. So we might say actually 7 of the 11 coldest temperatures on record have occurred since 1980. However, December 2010, I think this is a key point here, so I'll write this one on too. December 2010 then is the coldest month in 100 years. There we go, so there's one. So that would support a sort of snow and ice theory. Next, you might say, well, if we think about heat, we've had 10 of the warmest years. Let's put this on. Since 1990. So that would support our heat waves and our drought possibly. Again, let's go for another idea over here. So between 2010 to 14 then, we've broken many rainfall records. So that would be a great opportunity to use your Cumbrian floods case study. And so we can also say then, we've seen some major flooding events. Okay, only recently was Cumbria back on the news again for its flooding. So that would support the idea then that the UK's weather is starting to become more extreme. So all of those hazards we said that were there, these facts here might help back it up. So popular 6 marker, that one. So well worth pausing here, I think, and jotting these examples down if you haven't got them in your revision. Right then, the last bit I'm going to talk about is climate change. Okay, and in the exam you need to know these 3 things here. So you need to know, well, what are our big effects of climate change here? What's causing it? What's your management as well? Okay, so let's start down the bottom here then, shall we? Let's start with causes. So if we're talking about global warming and climate change, we're saying, well, global warming is our sort of sharp rise in temperature over the last century. Okay, so things like the greenhouse effect here are contributing to that. So our greenhouses are causing our gases to be absorbed then. Okay, so that outgoing heat from the earth. So increased greenhouse gas emissions obviously mean that the planet is going to warm, and that greenhouse effect obviously is taking place. So we can start to say, well, actually, perhaps there are 4 main human causes here that are sort of alluding to and causing us to experience increased climate change. So let's bullet point these on, shall we? I'll do them over here. So well, point number 1 then, we might say, well, that's our use of fossil fuels. Okay, so they're going to obviously release CO2 when they're burnt, so it puts more of that in the air. Next one we might say, well, increased sort of building work, so things like cement production isn't great for the environment at all. Okay, contributes massively. Finally, we might say farming. Okay, so livestock and rice paddies, well, they emit methane, not great for the planet either. And perhaps the biggest one, the one we probably know the most, okay, that's our deforestation. Okay, so the idea that we're chopping down trees, well, trees are storing our CO2, so for cutting those, not great at all. Okay, so those are all of our human causes. Let me draw a little person up here. And there we go. So if those are our human causes, we want to say to ourselves, well, what are our natural causes? So let me draw a nice tree over here. Okay, so point number 1 then we might have are our orbital changes. I'll explain what that means. So if we're talking about orbital changes, we're thinking, well, how much of the sun's energy then actually is going to reach the earth? Okay, if we've got more energy from the sun, we're going to have more warming. So we might say, well, the wobble of the Earth's axis varies, the shape of the orbit varies, the tilt of the Earth on its axis varies. So that obviously increases or decreases our exposure to the sun, so that warming. Number 2 here, we can put volcanic eruptions. Let's put that one on. So these aren't particularly good. So they eject lots of material into the atmosphere, which reflects the sun's rays. So the Earth's surface cools temporarily. And last but not least then, we can put here as well, solar output. So this changes in 11-year cycles. So if we've got reduced energy, it's just going to create us some cooler areas. Okay. So you might be thinking, well, how do we have evidence for all of this climate change? Okay, and they might ask you again for a piece of evidence to suggest that in the exam. But that would be things like your ice cores, so checking what gases are trapped in the layers, tree rings, so normally thicker rings mean warmer, wetter conditions, pollen analysis, so if you preserve pollen it shows different tree types in past climates. Okay, so all of those things there would indicate, they provide us evidence that yes, these things here are definitely starting to cause climate change. Okay, so now we need to sort of start thinking about what are our potential effects of this? How do we go about management of this as well? So if we go back to the top then and start thinking about effects, well, we're starting to see huge impacts. Okay, and we could talk about this for a long time, but we're just going to bullet point a few. So we're starting to see the shrinking of sea ice. Let's put that one on here. So huge environmental impact there. Some of our species are changing. Okay, so let's put that on there. So endangerment. So again, huge negative for the environment. Again, we might say, well, what we're starting to get now, again, let's put our extreme weather. So let's add that one on. Huge impacts. We talked about that, didn't we, right at the start? It's impacting us as people in terms of our crops. So lower crop yields also. Okay, well, it's not great for us as people. We're losing food. Okay, so all of those things there, it's just a drop in the ocean really in terms of effects. But again, I've just given you 4 big ones there. Okay, all of those are being caused because of climate change. Again, I reckon you could easily get more than I've got there, but it's just a few, as we'd be here a very long time. So let's have a little think then, shall we, about management. Okay, and management falls, I would say, into one of 2 categories. So it either falls into something that we're going to call mitigation, or it falls into the other side. Okay, and it's what we call adaptation. So I'll highlight those just to make it nice and clear. Okay, so I was talking about adaptation or mitigation. So if we think about mitigation first of all, well, that's just aiming to reduce the causes of climate change. So if we were going to mitigate, we might do other things like, let's add these on over here, planting trees. Well, that's going to mitigate because that will absorb more CO2. We might do things like international agreements. There we go. So things like the Paris Agreement, for example, where countries pledge to reduce their greenhouse emissions. Okay. COP26 would be another example there. So carbon capture, we could put on here as well. I'm going to run out of space, I think. So let's put that one at the top there. So all carbon capture and storage is storing those CO2 emissions then from things like power stations. So if that's mitigation, let's think about adaptation. So that's just responding to the effects of climate change. Well, if we were going to respond, we might think about changing our agricultural systems. Okay, so I'm just going to put agriculture here. So that might mean things like planting crops that are better suited to the climate, using things like biotechnology. Well, we'd need to adapt also our response to water, another huge resource here. So we might use things like water meters to limit use, for example. And then we might think about how we're going to sort of cope with the rising sea levels. Okay, so that could be things like flood warning systems, for example. Okay, so hugely popular maybe in low-lying areas. So investment in flood defences as well. So Thames Barrier there is a great example. Okay, all of those are just examples of how we would adapt to living with some of the challenges that are posed by climate change. Okay, so here's just a whistle-stop tour then of atmospheric hazards. And of course you've got more information in things like your revision guides. You've all got knowledge organisers, I'm sure, on Google Classroom from your geography teacher. But if you've got questions, please do come and see someone in the geography department. From here, I would suggest that you perhaps now watch the hazards revision videos for your case studies. So for here, you might have a little think about Typhoon Haiyan and Cumbrian floods. For tectonic hazards, you might have a think about Gorka earthquake and Tohoku earthquake as well. Hope you found this helpful.